Okay, thanks for joining us. Before we get started, I do want to take care of a couple of housekeeping things. It's a repeat for those of you who were on a minute or two ago, but you do have the opportunity to ask questions at any time through the questions pane on the GoToWebinar control panel. You do need to type your questions in, and then at the end of the broadcast, we will go through and answer those. So let's go ahead and get started. Joining me today is my partner in crime for the webinars, and that's Mrs. Marcy Tyree. How are we doing today, Marcy?
I'm good, Chuck. How are you doing?
I'm doing great. So today's topic is all about hands-on with high-speed data logging. Data logging is a very popular feature with Horner all-in-one controllers, and we're going to talk about some of the more advanced things that you can do with data logging. So let's take a look at the agenda. So we're going to start out with a data logging review. Again, some of you may be very familiar with data logging, others not as much, but it's all going to be good information. So hopefully those of you who are more experienced won't mind getting some of this information again. We'll talk about the functionality of the standard data logging features and some of the limitations. And then we're going to talk about all kinds of other things regards data logging as well. We're going to talk about high-speed data logging strategies. How can you take samples in measurements that are in milliseconds instead of seconds? How can you record, say, position and time with a higher degree of accuracy than normal? We'll also talk about dealing with data logging files. How can you move them around? How can you do things like rename them? How can you open them if you want to directly open a data logging file? And we're also going to talk a little bit at the end about utilizing the built-in data logger to its full capabilities versus custom programming to take it kind of to the next level. We want to expose you to that as well. And then, as I mentioned earlier, we will certainly be taking questions and answers at the end. Now, one thing I want to mention is I didn't pre-record any of the demos today, so we're flying without a net, which is fun. Now, we do that pretty often on our Tuesday live streams that we do and have been doing on YouTube every Tuesday at 2 o'clock Eastern. So we encourage you to join us for that. Today, we're going to be jumping around a little bit, but with not our normal tools for doing so. So we'll see how it goes. So let's start off with the data logging review. All right, so what is data logging? Data logging is a feature which allows any of the Horner all-in-one controllers to record machine data. And that machine data is going to be data logged as prescribed by the system designer. So whatever process information or machine data that you care about in terms of recording on a regular basis, you have the ability to record that information. And then that data log is recorded in a CSV file, which is compatible with a lot of programs, including Microsoft Excel. And configuration is really straightforward. So when we first created this feature many years ago, we decided as we were specifying it that we kind of wanted it to be, at least initially, data logging for dummies. And nobody is I'm not calling any of our customers dummies. I consider myself a dummy a good part of the time. But the whole point is we wanted to make it as straightforward as we can, and we think we've accomplished that. Today we're going to go through that, but we're also going to talk about some of the more advanced things that you can do. It's also, I think, important to talk about why data logging is important. So today more than ever, you'll hear all kinds of talk, and from us as well, about the Internet of Things and the industrial Internet of Things. Really, at the heart of that is a desire for manufacturers to get more out of their machines. They want data. Why do they want data? They want data for process validation. They want data because they want to make sure they're utilizing their machines efficiently to maximize their resources. They want historic operation type information because they have customers who want to do audits, who want to know that the parts that were manufactured last June were within spec when they were manufactured. And they want diagnostic information. So all those are reasons why data logging is more popular than ever. Now, in terms of data logging features, the data logging feature built into the Horner OCS all-in-one controllers, the data log files are recorded to removable media. And you have your choice between using the microSD card that you can plug into the built-in slot, And that's kind of the default path for data log files to be created. You don't have to specify a path, but if you do, that would be considered the A drive on an OCS controller. Now, if you prefer to log to USB instead, you can specify under the path, you can specify the B drive, and then it's going to go ahead and log to USB. Now, in general, we typically recommend microSD. It's less of the wild west out there in terms of the quality of the USB flash drives. So we generally recommend microSD. It's also really good in terms of temperature specifications. It doesn't have a lot of mass, so it's not really affected by things like temperature and vibration and those sorts of things, even though you might think it would be. And USB is a little bit more susceptible to the environment. When you do data logging, you effectively assign a group of variables that you're going to log to a spreadsheet, let's call it, okay? And you can have up to 30 variables as columns across the spreadsheet, and you can have up to, and that's in any group or any one spreadsheet, and then you can have up to 100 variables for your total application. So you might have, one group of 7 variables and another group of 35 variables and et cetera, et cetera. 30 variables is the maximum for one group. But again, you can have multiple groups just as long as you don't run up to either of those two limits. Now, when you configure each group, you're going to configure how often you do a data log. Is it going to be based on a period or a time period? You can set that up for as fast as every second, or is it going to be on an event basis, where you're looking for a variable, a bit type variable to trigger. And just a little hint here, we're going to take advantage of that trigger approach to do things faster than every second. But anyway, for the standard data logging feature, readings are buffered into RAM before they're written to removable media. So it's kind of the OCS is taking the data, reading the data, buffering it, and then getting the data onto the removable media through the firmware. So that's more or less how the data logging works. Files are created automatically. Again, the whole idea here was to keep it simple, so you don't have to think about creating new files or how to create new files or any of those sorts of things. It just happens automatically. The OCS takes care of it. If your sampling intervals are in minutes or longer, or for the triggered based sampling, those files are created every day. And then if your sampling intervals are in terms of seconds, every 15 seconds, 5 seconds, as fast as every 1 second, then you're going to be getting a new file every hour. Why is that? Well, we want to make sure that if you are, for instance, sampling as fast as every second, that you're not creating humongous files that are going to be difficult to deal with. So if you are sampling every second, worst case scenario, you'll be having a file that is created every day, so that file doesn't get too large. Now, in terms of how the files are named, first of all, since every data log group has a name, all data log files are contained within a group folder, so that's how they can be, separated, if you will. And then if the file is created every day, the year, month, and day are included in the file name. If the files are created every hour, the month, day, and hour is included in the file name. Now, once you've got the data logs created, the OCS is doing this for you based on your specification when you configure the system. How can you deal with these files? A variety of ways you can deal with the files. One way is to use FTP. FTP stands for File Transfer Protocol. It's a standard Ethernet protocol that the OCS has supported for some time. It's a great way for you to be able to pull files off the OCS, a microSD card, so that they can be processed, maybe archived somewhere, processed, whatever the case may be. And FTP is a very inexpensive way to do this as well. There's a whole multitude of FTP clients available commercially, many of which are free, some of which have modest costs to them. And a lot of them support things like scripting that allow you to kind of automatically transfer the files based on time of day, et cetera, to set up automatic backup functions, all those sorts of things. Now, at Horner, we also do offer a utility for sale as well. That's called Envision FX. It does support scripting, But it primarily was created for customers who are utilizing the transfer of data over serial port. Now, Ethernet, of course, is the common way to do it, and FTP over Ethernet is the fastest way to do it, frankly. But for those customers who, for whatever reason, need to get the files off and they don't have an Ethernet port available, Envision FX is available for that scenario. Although I believe you can also use Envision FX with Ethernet as well. Now, in some cases, you may want to deal with the files while they're on the OCS, especially when we start talking about some of the high-speed data logging that we'll be doing. You may want to, after you create a high-speed data log file, you may want to rename it. You may want to copy it, whatever the case may be. And really using the copy function that is available in the OCS instruction set is another strategy for dealing with the files. For instance, you could program in a copy function that copied all your data log files from the normal directory on the microSD card to a separate USB drive that might be plugged into a standard USB extension cable that's available on the outside of the enclosure. So that's kind of the equivalent of the old SneakerNet manual way of grabbing files off of the OCS, is by basically having someone walk up, plug in a USB drive to the outside of the enclosure through an extension cable, and then have them press a button on the unit, which triggers a copy function, which would then copy complete directory of files, for instance, from the microSD card over to the USB drive. So that's definitely another capability that's there when you're talking about dealing with the data logging file. Now, what about viewing data logging files? Once you've got them off the computer, if you're interested in taking a look at the data, there's a whole variety of ways to do that. Really, using spreadsheet files is probably the most common way that people deal with that, and we'll be demonstrating that during today's session. Okay, so this is where we start the kind of live without a net portion of our presentation today. So let's go ahead and dive in. I've loaded Cscape here, and I've got an XL4 in front of me. So you can see down here in the lower right, I'm live or connected to my OCS. It happens to be an XL4. All right, let's go ahead and just set up some real simple data logging just to get us acclimated again with the data logging feature and to show you how simple it is to set up the basic capability. So let's go to the program menu. Let's go to data log configuration. So the first step is you have to enable data logging as a feature, and I've done that previously on this dialog box. The next step is to set up some global attributes. I'll do that here, and you can see I've previously accomplished that. There's a global status register, which you can use to monitor the feature. You know, is the memory card plugged in? All those sorts of things. And then there's also a global enable variable as well you can set up. In this case, I've just left that always on so that we can just always be able to data log. Now, later on in some of my higher speed demonstrations, we'll change that from the always on variable to something else. But that's how we have it set up to start with. And for standard data logging, where you're not excessively data logging at an extreme rate, this is a good approach. Okay, so for basic data logging, we want to start out by adding a group. Okay, and I'm going to add this group. I'm going to call this process. Okay, and again, this is not only the name of the group, but it's also the name of the folder in which the data logging files will be contained for this particular group. Okay, so we've created the group. Now let's go ahead and add some variables to the group. And I'm going to keep this extraordinarily simple. Let's just go ahead and grab a temperature value from one of our predefined variables and then add that here. Now, normally you could add, you know, again, up to 30 different variables of all different types: integers, double integers, floating point, ASCII, Boolean, you name it. Those are all able to be added, again, up to 30 variables for any individual group. And then when that spreadsheet is created, if you want to think of a data log file as a spreadsheet, effectively the column header at the very top of the spreadsheet is going to be the name of the variable. So you're going to want to, when you're actually ready to configure your data logging, you're going to want to have all your variables established and named with reasonable names, because that's what's going to show up in your spreadsheet, if you will. And then also by having everything named and effectively your application done, it's going to be a lot easier to just kind of pick those variables off of the list and get them added. Okay, so I've created a group. I've added variables, in this case, just one to the group. Now I'm going to go ahead and go to group attributes. And this is where I kind of finish up the configuration. Now I have the ability to assign a group status register that gives me even more feedback on terms of how things are going with this particular group for data logging. I'm going to leave that blank for now because it's an optional feature. So I'm just going to gloss over that for now. Normally I would always fill that in a real application, but for demonstration purposes, I'll go ahead and leave that blank. This here is where we configure what our data logging interval is going to be. So let's just make this, say, every 5 seconds for this test. All right, so we're making it every 5 seconds. Data log path, that's where you would fill in, if you wanted to log directly to USB, you could fill in the B drive here. If you wanted to create a subdirectory where underneath where the process folder, in my case, is housed, I could put that here as well. But I'm just going to leave that blank, and that means that effectively the process folder is going to reside in the root directory of the microSD drive. And then we have the flexibility of setting our date and time format as well. Okay, I'm going to go ahead and just press OK. So let's just go ahead and quickly execute this particular data log. Very simple. All right, not a whole lot to it. I'm going to go ahead and download to my controller now. Okay, so while I'm downloading, I do want to mention that every Tuesday we are having live events on YouTube where we have a topic that we're covering. We have some really nice tools to be able to show you the products as well as the software live, and it's a good venue for asking questions throughout and those sorts of things. So I just wanted to mention that to you. Okay, so the program has been updated in my XL4, and that's currently running, and it should be data logging. So let's see if we can find out if the data logging is happening or not. I'm going to go ahead and, because I don't have a camera available with this webinar package, I'm going to go ahead and pull up a FTP client. Okay, with this FTP client, this one happens to be FileZilla. I am connected to the XL4, and these are my login credentials for FTP. I'm going to hit Quick Connect here. It's going to go ahead and reconnect with that OCS and do effectively a refresh. And look what we found here. I'm looking at the directory of the microSD card, okay, and I'm seeing a folder called process. That's what we want. I'll double click on that, and now I've got a file that's named based on the month, the day, and the hour, okay, because again, my interval is in seconds, so it's creating a new file every hour. So at the top of every hour, it will create a new file. Let's go ahead and download this file. I'm going to go ahead and download it to my computer. All right, so it's now been downloaded. All right, you'll see that file there. I'm going to go ahead and pull up Excel now, and let's go ahead and take a look at that file. All right, I'm going to do a file open, and with Excel, you can either import the file or you can just go ahead and open it. And generally, I just go ahead and typically open it. So there's the file. I've already in the proper directory. Let's hit open and let's see what we've got here. All right, so as you can see, again, very simple. All we have here is date and time and value. And you can see it's logging every 5 seconds. All right, I didn't let it get very far before I downloaded the file. So this file, as when I downloaded it, had this many entries, again, every 5 seconds. And I could have, again, a whole series of columns here. But again, here we go with the date, the time, etc. So this is the standard data logging feature. Let's go ahead and close that down. And let's start taking a look at how we might do things in a little faster fashion. So let's go ahead and go back to our slideshow and cover some of the things that we can do before we start demoing the higher speed option. Okay, High-speed data logging strategies and demos. That's the next section of our program. Okay, first a disclaimer. I'm going to be demonstrating how to log machine and process data at rates much faster than every second. Okay, if high-speed data logging is really important, use the XL series. The XL4 on up would certainly be appropriate for high-speed data logging applications. Now, our XLE, our XLT, our micro series products, those are our budget products. Those are great products, a tremendous value, and they do really well with standard data logging, no problems whatsoever. But when you want to start pushing the envelope for speed, you certainly should be considering first, at least, our XL4 on up type products in the rest of the XL series. Because at these sample rates, you should also consider the fact that you really can't sample continuously. If you're going to be taking data, let's say every 20 milliseconds or so, you aren't going to want to be doing that on a continuous basis. The high-speed data logging you're going to want to do should be done in bursts. Maybe during a certain part of the machine cycle, or maybe when you want to run a special test on demand, those sorts of scenarios. You're not typically going to do high-speed data logging continuously. Now, standard data logging, you can do that continuously, and you can mix and match between doing continuous data logs and doing high-speed data logs, etc. But if you're going to be data logging at a high rate, you're not going to do it continuously. Now, last disclaimer here, and that is if you're looking for samples every millisecond, like clockwork, and that's critical data, also consider a dedicated data logger. The OCS is extremely versatile. It does data logging really well, but it's also trying to control the machine or the process. And there's a lot of things it has to do besides data logging. So if data logging is the primary thing, and 1 millisecond type rates are absolutely critical, a dedicated data logger might be the way to go instead. Now let's start talking about how we can start sampling in terms of milliseconds instead of seconds. And again, for review, when you're using the standard data logging function, the shortest interval you can specify is 1 second. However, as I intimated a minute ago, we can be creative and utilize the triggered only approach in combination with some ladder code or in combination with some special system bits. Now, the OCS comes built in with a couple system bits that are of interest, one of which is T100 milliseconds or %S4. That's a bit that is turning on and off every 100 milliseconds. So every 100 milliseconds, that bit will go from off to on. Another similar bit is called T10 milliseconds. That's S3, and that turns on and off every 10 milliseconds. Now, I will say this, for a lot of applications, you're probably going to be pushing the envelope to be able to really use S3 because maybe the regular scan rate in your controller is 7 or 8 or 9 milliseconds. And so you're probably not going to get the very best results by using the S3 bit. But let's definitely take a look at the S4 bit, which again is going to give us 10 times the normal sample rate that we could get with a time interval type configuration. Now, the next thing I'll talk about, and I'm going to demonstrate how to use the S4 bit here in a minute. Another thing I'll be demonstrating also is if you effectively want to go just about as fast as possible using the standard data log type object, you can write a little bit of logic, and I'll show it to you. It's quite simple, that effectively will flip-flop a trigger bit so that you can be sampling every other scan. So the S4 bit, for instance, is going to be turning on and off every 100 milliseconds, whereas the flip-flop logic we could write would effectively allow a trigger bit to turn on every other scan. So if your scan rate is, let's say, around 3 or 4 milliseconds, you could be looking at samples, let's say, in the 8 to 10 millisecond range. So that is probably about as fast as you're going to be able to go while utilizing the standard data logging type feature. Now, another thing I will mention is once you start sampling faster than every second, now the timestamp that gets automatically placed on the data log, while important, doesn't have as much meaning as it, or at least does not have as much resolution as we might otherwise want. So I'll show you how you can very easily add a time base of, let's say, in milliseconds to your data log that will allow your data log samples now to have more meaning in terms of the timestamp at least. Okay, so how will we do this? And I'll show it to you in a second. But effectively, we're going to just use a regular old timer. We're going to set the time base of the timer to 1 millisecond. So the accumulator of that timer is going to be in terms of milliseconds. We'll configure that timer as non-retentive. That means that the timer will reset to 0 when it's reset, when it doesn't have power. That'll make it really nice for having the timer active while we are running the test. We could also set it up for a longer test. We could also set it up so that that timer expires automatically every second and restarts every second, so that we effectively have a millisecond range that we can look at, but we won't be doing that in this example I'll be showing you. And again, if the duration of the data log is time-based, in other words, I'm going to run a test, and let's say that test is going to run for X amount of time, let's say 5 seconds, then we can use that timer also to time the duration of the test, which is useful. And if the duration is not time-based, then it really doesn't matter where we set the preset for the timer. We just want to use it for a display of milliseconds in our data log file. So that's a trick we can use, if you will, for showing milliseconds or increased resolution of time in our high-speed data log. All right, now let me go ahead and go back to Cscape, and let's go ahead and do a little bit of high-speed data logging this time. What I'm going to do is I'm going to go ahead and go back into data logging. All right, and I'm going to go ahead and add another group. Okay, we've already got our process group there. I'm going to call this group high underscore speed. All right, let's do that. Okay, now let's, one thing I want to mention, back when we were doing our process logging, okay, we used for global attributes, we used S7 or always on so that data logging would always be enabled. Now, that works fine for standard data logging of 1 second or slower, but when you're doing high-speed data logging, that may not be the best approach, depending on what kind of logic that you're running here. Okay, but so for now, what I'm going to do is I'm going to make it so that my data logging is not automatically happening all the time. I'm going to set up a bit that is going to allow it to start. So that's a change I'm going to make here. So I'm changing that to, I've got a log start bit now. Okay, so I've created my group, but I haven't added any variables to it. Let's go ahead and add a variable here. Let's go ahead and just add, like we did before, let's just add our a single analog variable. Let's go ahead and add one called pressure here. All right, which is an integer. And let's just keep it simple, and we'll leave it at one variable for this as well. We'll go under group attributes. We'll leave the status register blank again here, which I wouldn't do in a real application, but I will for a demo. But instead of selecting 1 second interval here, let's select triggered logging only. All right. And since we selected that, we now need to fill in the register that we want to trigger the actual data log. And in this case, I'm going to go ahead and utilize the T100 millisecond system bit, so S4. All right. All right, so let's just leave it configured that way. So what that basically means is this. So I'm going to be taking a sample of the pressure variable every time S4 turns on, which is every 100 milliseconds, and T11 bit has to be on as well. Okay, this is going to enable data logging in general, and then when that is on, I'll start taking readings every 100 milliseconds. All right, let's just go ahead and download that configuration here. All right, I'll go back and hit the download button to the XL4. Okay, it takes a little while for Cscape to figure out what it wants to download. Now it's downloading it. Okay, so nothing should be happening yet from a data logging standpoint because remember T11 is off, or well, we think it's off. Let's make sure it's off. Here we go, there's T11. Yep, it is off, so there should be no data logging happening. I'm gonna go ahead and turn it on. All right, and then I'm gonna go ahead and turn it off again. Because remember, when we're doing our high-speed data logging, we kind of want that to be a on-demand type scenario. All right, so I should have performed a short data log with a folder called high speed. So let me close this here. Let's go back to our FTP client. Let's do a refresh. And there we go. We now have a new folder called high speed. Double click on that. All right, I'm going to go ahead and download this file. Now, you'll notice it has the same name as the other file I downloaded. So if I was a little more sophisticated and this wasn't just a demo, I would copy this file to a new location, or I'd copy the whole folder, whatever the case may be. Let's just go ahead and do that, just for grins. Let's go ahead and just copy the whole high-speed folder. We can do that. I'll hit download. All right, so I've done that. Let me go back to Excel. Let me open up this file. Okay, there's my high-speed directory. Let's pull this file up and let's see what we've got here. Okay, so what we have is now we've got suddenly a lot more readings. So if you'll notice here, here's my timestamp, and that's at 14:33 and 29 seconds. And I only got one sample in during that second, and then I switched over to 30 seconds. And let's see how many samples I got in the 30th second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, sure enough. So I got 10 samples in within every 1 second. And the duration of my test, I don't know, how long did my test last? I went from 29 seconds to 37 seconds. So in an 8-second test, here's the data I have. And obviously in this case, I only had one column. All right, but this is where I think you kind of get the idea that once you start taking readings faster than every second, you do want more resolution on your time than strictly down to the second. It's not strictly necessary, but it probably would be useful to look at. So why don't we go ahead and do another test? And this time, let's get a millisecond timer created, and let's go ahead and get that added into another data log. All right, so I'm going to go back to Cscape here. All right, here we are in Cscape. All right, let's go back to data logging. Now, before we do that, let me show you how we are going to add time in milliseconds. So I've got another section of my main logic here where I have a timer. All right, so what I've done is I've added a timer with a 1 millisecond time base. Okay, and in this case, I've set it up so that I'm going to go ahead and use this timer to time my test, and I've decided I'm going to run my test for 1 second. So I'm going to do a data log for 1 second. So my preset is 1,000 milliseconds. Okay, it's a non-retentive timer. All right, and then what's going to happen here is I'm going to turn on a T1. All right, and when T1 is turned on, this timer is going to execute. And what else is going to happen? Well, this is the logic I was talking about in my presentation about creating kind of a virtual flip-flop that takes a trigger bit and alternates it every scan. So what's happening here? Well, while my test is running, this contact is on, and then if the stored value of my trigger bit is off, in other words, last scan, my trigger bit was off, then I'm going to go ahead and turn it on. All right. If the stored version of my trigger bit was previously on the last scan, I'm going to go ahead and turn it off. And this is the rung that I use to effectively record what the trigger status is now to a bit that I can recall next scan. Okay, so this is just a simple little bit of 3 lines of logic that you can use to quickly create a trigger bit that alternates from one to the other. Okay, and we can also throw in this accumulator of this timer to get a millisecond value in our data log as well. All right, so let's go back into data logging. All right, so I'm going to go into program data log configuration, which is where I've been. Okay, I'm going to go ahead and add another group. All right, I'm just going to call this faster. All right. All right, I'm going to go ahead and, again, to keep it simple, I'm going to start adding variables, but this time, the first variable I'm going to add is going to be that millisecond timer accumulator, okay? So I happen to remember that that was R1. There we go, test timer underscore milliseconds. All right, that's going to be the first variable that I log, and then I can just start adding my other variables. I'll go ahead and add the temperature value. Okay, and I'm going to go ahead and add the pressure value just so that we have a little more interest in this one. There we go. All right, so I've got my millisecond is going to be the first thing after my timestamp. Then I've got a temperature and a pressure, and again, I could add a lot more if I needed to. Let's go into group attributes. Again, for demo purposes, I'll leave that blank. And we're definitely not going to be going with a time-based log. We're going with triggered logging. But our trigger bit is not going to be one of our, T100 millisecond bits or something like that. It's going to be that flip-flopping trigger bit that I created in Logic called trigger. All right, there we go. So now that is fully configured, this group called faster. I'm going to go ahead and delete this high speed group. All right, so we don't have any conflicts there. All right, I don't have to, but I'm going to go ahead and do that. And then I'm going to go back here under global attributes, and I'm going to change this enable register back to S7. Why am I doing that? Well, because I'm in ladder control over this T2 trigger bit, so I can just start and stop that test on demand, so I can go ahead and leave this global attribute always on. Okay, so there's the new data logging configuration. Let me go ahead and download that. And again, this is going to allow us to ultimately log as fast as possible using the standard data logging feature. Okay, so we're downloading that to our XL4. All right. Now, from the standpoint of the new data log group that we just created, it's not actually data logging yet because that's done on demand whenever this T1 test is initiated, that bit is started here, okay? So I've turned on the debug mode, and I'm gonna go ahead and trigger this test. And I happen to have a button on my XL4 that you all can't see, I'm gonna use to trigger that test with. Okay, so you can see that test bit turned on for a second. All right, I'll go ahead and get out of data log mode, and then let's go back to our FTP program and see what we see. We need to hit refresh. Oh, we didn't get it. Did I screw something up here? That's what we're looking at. Oh, high speed, quick connect. I don't see that. Hit OK. Okay, so I must have screwed something up in the configuration. Let's go back and take a look. That's why we want to check things out here. Okay, so let's go back to program, data log configuration, process faster. All right, so we're configured for always enabled. Okay, we've set R1, AI5, AI1. Our group attribute is T2 for triggered logging only. So that all looks good. This was working in the pre-show testing. I must have done something wrong here. Let me see. Triggered logging only. All right. Our program is equal. Let's go ahead and run the test again. All right. It looks like it's triggering okay from the screen I created. Let's go back to our FTP. All right. And I'm going to go ahead and hit quick connect. Okay. Let's go back a level. Okay, let's try reconnecting to FTP. So aren't you glad that you are getting a chance to see a live demonstration where everything doesn't go perfectly? All right, so to get connected over FTP, I'm going to type in the IP address of the OCS, which is 192.168.0.191. I need to type in the username for FTP, as well as the password, and then I hit the Quick Connect button. Oh, look at that. So I'm not sure why the refresh wasn't working before, but it obviously worked that time. So I just had to reconnect with my FTP client. So we're going to blame it on the FTP client, and we're not going to blame it on Chuck today. But let's go ahead and double click under the faster directory. Okay, and there's the file we were looking for. I'm going to go ahead and download that entire folder. All right, now let's go back to Excel and let's take a look at that guy. So I'm going to hit File, Open, and I don't want the high-speed directory. Let's go back to Datalog, go to the faster directory, pull up the file. Okay, so here we go. So now we have, what do we have here? We've got timestamp with date and time in seconds, of course, or down to the second. And then we now have milliseconds in the next column. All right, so we not only, and then followed by our two data columns, our temperature and our pressure. So we not only have, timestamp down to the second, but we also have timestamps in the milliseconds. And you can see here that if we go to let's go down to, on this 29th second, we are going to go how far down? We should be going, I hope you aren't getting dizzy here, I apologize. Okay, we're going down to column 80. Okay, and then we make it to the 30th second, and we go down another 20 or so. So effectively, we were able to get, we're on row 114, was the last sample for that test. This was for the second test I ran when I couldn't see the file. So from 114 all the way up to 2. So that means that we were able to get 113 samples in a 1-second test. So a little bit faster than 10 milliseconds was our sample rate there. Okay, so that should give you an idea of some strategies that you can use to still use the standard data log object, but to actually take samples for your data logs at much faster than once per second. Well, let's go back to our presentation. I want to show you a few more things before we get to the question and answer session. Okay, so what if, we've talked a little bit about displaying your time in a higher resolution on your spreadsheet or in your data log file. What about position? Well, encoders are great for that. So if position of the rotary position of a stroke or the linear position of a RAM or something like that is critical to your high-speed data log, then something like an encoder, which is probably already on the machine, is going to provide great information in terms of a high-resolution position for you. Okay, and the XL series OCSs can support up to 2 encoders through the built-in I/O. Okay, if you need more than 2 encoders, there are some options. We do have a RCC 6512 high-speed coprocessor that can support up to 4 encoders. And then we've had plenty of customers utilize CANopen-based encoders that are synchronous. That's one of the benefits of CANopen is you can synchronize encoders even if they're on the network. So that's another strategy if you need more than, say, more than 2 positions that you want to log in a high-speed basis. So again, encoders just really can't be beat for recording position with a lot of detail. Okay, now here's a question I've been asked before. Why can't I log every scan? Because if you just saw our last demonstration, we were logging every other scan. Well, the answer is yes, you can log every scan if you choose, but you can't do that using the built-in data log function. So in that scenario, if you want to data log every scan, you can do it. It's just a completely manual process, and you're going to take advantage of some special instructions in the OCS instruction set to accomplish that. So the general process is going to be, first you're going to initiate a test, kind of like I did by either turning T11 on in the second demo or hitting the button on the OCS in the third demo, but you're going to initiate a test. And then instead of that trigger, if you will, for the test, initiating a data log, what it's going to do is it's going to initiate some logic you will write, probably utilizing a shift register to effectively, every scan, record away the data as well as elapsed time from a millisecond-based timer. You're going to record that away into internal registers. Now, keep in mind, the XL series OCSs from the XL4 on up have potentially 50,000 registers that are available. So if you wanted to, if you had a data log of 5,000 registers or something like that, that wouldn't be out of the realm of possibility. Again, keep in mind when you're doing high-speed data logging, you're going to want to do it on a batch basis, on a periodic basis. But anyway, you're going to go ahead and use a shift register or something similar to store that data from your sample every scan into a series of registers. And then once your test is complete, after that, then you're going to go ahead and use the removable media write instruction to create your log file. So you won't be taking advantage of the data log function built into the OCS firmware. You'll be writing your own logic to make that write to memory card happen, creating your own CSV file, if you will. Now, if you are logging every scan, there's some things to consider when you're writing this logic. So if you're using register-based ladder, then you need to think about the fact that with the removable media write block, for every different type of data that you're going to write from column to column, you need to have a separate write function block. Okay, so that is something to manage. And you also have to make sure that in your logic, only one write function block is active per scan. That's important as well. For those of you who are using variable-based languages, whether you're talking about advanced ladder with variables or advanced ladder with tags, as it's sometimes called, or if you're using our IEC package, we have a new feature we've added recently. I believe we added in Service Pack 3, which effectively allows you to utilize a structure for all the data that you're going to be logging or writing to the removable memory card, create a single structure, and then you can greatly minimize and streamline your logic for writing that file, because instead of having to create a new write function for every different type of data that you're writing in every column, you can utilize that structure in one instruction, and again, greatly streamline the effort required to log data in that fashion. So I'm not going to show you specifically how to do that. That's a little bit above and beyond this particular webinar, but I do want to assure you, you can log data every scan, but it's certainly more work, but it can be accomplished. So that is the program I wanted to show to you today. Let's see if we have any questions. I don't see any questions at this stage. So I do want to, if you're still thinking of your questions, feel free. Here we go. Here's a question. Can you data log to an SQL database? So not directly at this time, no. That's something that we're looking at. I'm sure we'll be, actually, it's not just looking at, we actually have it on our roadmap for post Seascape 10. So, a few months after Seascape 10 has been released, which is coming up this summer, we should have some more direct solutions for logging to an SQL database. Now, there's plenty of ways to do that, right? There's plenty of ways to take a CSV file and get it into a database. There's plenty of ways to push data, let's say, using MQTT to an MQTT broker, and then use software packages that are available commercially to get that data from the broker into a database. You can use commercially available OPC type products from companies like Kepware, as well as Software Toolbox. They offer packages for being able to take either CSV data or MQTT broker type interface and getting data into database. But in terms of a direct solution, 100% from Horner, we're not there yet. Okay. Okay, is the 1 millisecond logging time restriction only to certain models? So I hope I didn't deceive people through my titling of my slide. So what I meant to say in my slide was that if you're measuring your data logging in terms of milliseconds instead of in terms of seconds, then you should be using the XL4 or up, okay? There isn't a Horner product that allows for 1 millisecond type logging. So we don't have a product like that, a dedicated data logger, if you will, that can log data as fast as every millisecond, with super precision, that sort of thing. So that was a question from John asking about 1 millisecond type logging. So we can't do it as part of a Horner standard product. Keep in mind, our standard OCS products are full controllers, so they're controlling the machine, they're doing all kinds of things besides data logging. So if you do need 1 millisecond level resolution and accuracy, then there are, third-party data logging, and they're quite expensive, frankly, but third-party data logging tools available. Okay, those are some good questions. All right, I think that is it for the questions that we had today. Again, I want to thank you for joining us today for this session. Keep in mind that every Tuesday we have a live session where we cover a different topic. We happen to use YouTube for those, or we have been so far this year. We're getting ready to try out some new tools for you as well to be able to give you even better content. So keep checking back with our website and get on our email list. We won't bombard you, but we'll let you know what's coming. And we'll try and provide you some good content that's always available, either live or for viewing at any time from our website or from YouTube. Everybody have a great afternoon and stay safe out there.